Today we will solve the questions related to the key concept 12 about energy, about kinetic energy, potential energy, and law of conservation of energy. These are the basic things about that we will solve the questions. Like, first look on the first question here. Draw a graph. Please read the statement carefully for every question. Of extension against the load. These two words are very important. We must have concept what is the mean by the load, what is the mean by the extension. According to Hooke's law, these two quantities, extension and load, they are directly proportional to each other. More load, more extension in the spring. And whenever you will apply a load, its length will increase. This is called extension. And if you draw the line, graph line, it will be a straight line that will pass through the origin. That is the first part. Okay, if you go here in the second part, this one, first part was that just to draw the graph lines. Okay, draw a graph. We have to draw this line. We did it. State the word used to describe the energy stored in a spring. Now, what kind of energy is stored in a spring whenever you apply a load? Okay, so that energy is named as elastic energy. In the spring, when it is compressed or extend, the energy stored in the spring is named as elastic energy. So your answer will be here if you write here elastic energy. Okay, this energy that is stored in springs. Elastic meaning object come back to its original position. This is called elasticity when the external force is removed. In all these spring, this is a property to some extent. Okay, so the energy that is stored in the spring you will call as elastic energy. So your answer will be here elastic energy. Okay, now you read the B part. Shows a model train. This model train, you can see that it's at a speed of v approaching a buffer. The train of mass 2.5 kg is stopped by compressing a spring in the buffer. After the train has stopped, the energy stored in the spring is 0.48 joule. Calculate the initial speed of the train. So for that purpose, we will use here a relation for kinetic energy. You know that when the train is moving, because we are concerned here about the train initial speed. When the train was moving here, what type of energy it has? It has kinetic energy when the train was moving. And we know that what is the formula, what is the equation we are using for kinetic energy? Kinetic energy is equal to 1/2 mv square. This equation will be used to calculate the initial speed of the train. Okay, the energy that is stored in the spring is 0.48 joule. So that energy is basically from where this energy come? It's come from the kinetic energy. So we can write this saying 0.48 is the energy that is given you in the problem. Okay, joule. 1/2 mean 0.5. M, what is the M? M is given you mass. Here in the problem you can read mass is 2.5 kg. So you substitute its value 2.5. Okay, V means speed. Speed we don't know. Speed we have to find. V is question mark. So here is the V square will come. So whenever you will solve for V square, this problem, you will get this thing like that. V square will be equal to 0.384. Now you take under root or square root on both sides because we want to find the value of v, not v square, initial speed. So your answer will be 0. After taking the under root 62 meter per second. So these all steps you have to show here. You must write the formula for kinetic energy, put the values and solve it for V, and unit also be mentioned there. Okay, The unit for speed is meter per second. Now we come to the second question here. If you look here, second question is where it will be on the second page. We'll go there now. Okay, this figure, question number 2, please read it first of all carefully. We have to find here the gravitational potential energy. Okay, so look here, figure 2.1 shows a conveyor belt transporting a package to a raised platform. Whenever you will raise something, here is the package, it will go to the height. This height it's going to this height. Okay, so whenever it will go to the height, it will have some energy stored in it in the form of gravitational potential energy. The belt is driven by a motor. What is the mass of this package? This is the important thing, 36 kg. Calculate the increase in gravitational potential energy, GPE, we have to calculate. This is the aim of this question. When it is raised to a vertical height, how much height it covers? Whenever you raise, height is 2.4 meter. This is the height. Against it is raised. Okay, now we have to find the gravitational potential energy. So this energy is due to the position of the object, because its position was changed. Before this package was here on the ground level. Okay, now you raise it to the height. So how much height it gained? 2.4 meters. So how much energy will store due to its height? You will use the equation for gravitational potential energy. Okay, GPE will be equal to mgh. Here look that, read this problem carefully. Whenever you face such problem, you want to calculate like gravitational potential, you must find where is the mass. 36 kg. Kg is the unit for mass, standard unit, SI unit. So for mass you will write here 36. The value of gravity is 10 almost. Okay, and what is h? 2.4 meter. So simply multiply with these three quantities and you will find the increase in its potential energy as it moves from the ground to the height h. So that potential energy is 864 joule. Joule is a unit for energy, any kind of energy, kinetic energy, potential energy, okay, or any other kind of energy. You will use proper SI unit for energy is joule. Okay, second thing is that now we have to find the package is raised through a vertical height of 2.4 meter in 4.4 seconds. Calculate the power needed to raise this package. Power mean energy over time, work done over time. We can use this relation. So now look that how much time it takes to move this distance, 4.4 seconds. So it means that you can find the power, no, energy over time. So what is energy we have? 864 joule. Okay, and what is the time we have here? 4.4 seconds. So if you divide 864 with 4.4, okay, you will get 196 watt. 196 watt. Watt is a unit for power. Okay, keep in your mind please. Thank you. So this was something about these questions. Now we'll go to the next page, or the C part as well. We'll try to solve it. C part, if you look here, how you will solve the C part. Please read first. It's very important that you read the question, because if you not read the question, how you can understand it? It's impossible. So that is C part, please look there. The electrical power supplied to the motor is much greater than the answer B. Okay. Explain how the principle of conservation of energy is applied to this system. This is a very important thing. We have to explain that, okay, where does energy go? Okay, this is a very important question. Basically, the thing is that some of the energy is wasted in the form of heat. Okay, So law of conservation of energy is applicable there, but the output is not equal to input. Output and input are different because some of the energy is dissipated or wasted there. Understand this point? So we can say that according to law of conservation of energy, initial supplied power, initial energy should be equal to the final energy, okay? But the problem is that some energy is dissipated into the surrounding. Difference due to the increase in internal energy there is a more thermal energy is wasted, okay, because belt, motor, surrounding, all these things. So principle of conservation of energy is applicable here. According to this principle, we can write this thing that initial energy equal to final energy, okay. This is a statement for law of conservation of energy, that the initial energy equal to final energy. But here say it's less. Why it's less? The reason is that we can mention this thing. Simple reason, because there is a belt, motor is moving, so definitely energy will be wasted. Okay, in what form it is wasted? Let's see that. It is wasted in the form of heat. So law of conservation of energy is applicable to it. Okay, so in this way, so you must mention here that in what form energy is dissipated. Dissipated means wasted into the surrounding, in the form of internal energy, heating, thermal energy. These words you must mention here. Energy is some energy, we can say some energy is dissipated. Dissipated means wasted. Okay, where it wasted? Into the surrounding. In what form? In the form of, we must mention here these proper words, in the form of thermal energy, heating. So we must, this will be your complete answer. Okay, electrical power supplied to the motor. Explain how the principle of conservation of energy is applied to this system. If the initial energy equal to final energy, it's okay. Yeah, it's also okay here, because some energy is used as useful output, but the other is wasted. So this system is also applicable here. Thank you so much. Now if we look here, page number 3. Okay, now in page number 3 looks that assume that the power available to raise a package is constant. Okay, a package of mass greater than 36 kg is raised to the same height. Suggest and explain the effect of the increase in mass on the operation of the conveyor belt. So whenever, before, how much mass it was? Before the mass was less. So what will be the effect on it now? Let's see that. Increasing in potential energy of mass is increased. Simply potential energy will be increased, because what happened here? If you look here, the mass has increased. Sorry, I will use a different color. Okay, when the mass will be increased, look here, the mass has increased 36 kg. In first part, what was the mass? Assume that the power available to the raise of package is constant. Package of mass greater than 36 kg now you introduce. So when power is the same, but the mass has increased now. So in that case, increase in potential energy of the mass is greater. Okay, or we can say that if you look here, what will be effect on it? Power equal to what thing? Energy over time equal to what thing? Energy over power. So energy has raised. So when the energy will raise, E will become greater. What will affect on the T? T will increase. It means that system will become slow. So you have to write this thing in any form of power is constant. So speed reduced, time taken is longer. So this thing will be the effect on the system because P is constant. Look now, the value of E has increased. When the E will increase, T will increase. T increase means it takes long time. Long time means the system has become slow. So you will write here in any form that power is constant, speed reduced, time taken longer. So these words we must mention here. I will write here. Speed reduced, or we can say time taken longer. Thank you.